So this is the M6, in case it's not in focus. That is 500,000 MSRP in Europe, 500,000 euros. So hi, we're here at Munich High-End again, and welcome. Say hello to Michael Børresen. Say hi.
Hi, hi Alan. It's nice to see you. And
so, what do we got new today?
Actually, we have a lot of things, but I'm standing right next to our pride and joy, the M6, which is our current flagship speaker, and I'm quite proud of it. So I think it has a lot of the knowledge that we gained over the last 20 years working in the speaker business.
In what way? What's new about it?
Everything is new about the speaker.
Okay.
Driver technology is also new for the M series. We have drivers that are made quite different than anybody else.
Right.
We always had different drivers, but this one is
really
unique.
Here's one I prepared earlier.
Yeah. This we have a silver version of our iron-free magnet system. And the idea of the iron-free magnet system is that iron pushed up near saturation by the permanent magnet is unlinear, because the voice coil, which is itself as a small magnet, can easily relax the flux while it cannot push it higher because the iron is near saturation. So you get a built-in dynamic unlinearity in that. And this one takes that away because it do away with the iron. Instead, we get the flux by pushing two rings of neodymium N52 close together, and you push north to north and south to south, and that creates a fantastic dense magnetic field, but without the iron to conduct the flux. Instead, we have two pole rings of silver, and there's half a kilo of silver in a driver like this, and for some it may seem obscene really to put that much silver in. Is it really needed? And yes, it's needed, because copper and silver have that element of locking flux to one level. It doesn't like flux change. So the flux, the permanent magnets gives, they will fight to keep it at that level. Once it's assembled, you have that flux. So the voice coil has a much harder job of changing the flux in the magnet gap. And that leads to a firmer foundation, lower inductance in the driver, and a much, much faster rise time, and rise time equals resolution.
Please apologize. I'm sorry for that.
So the magnet motor is fantastic. The voice coil, instead of having, normally you wind the voice coil down and you wind it up, here we have two parallel windings, and that halves the inductions as well. So when you look at this driver compared to other standard drivers on the market, it has maybe only 1/10 of the induction. And why is induction a problem? Well, inductions is like a dynamic brake, but it's also inductions that creates the back EMF in a driver, causing difficult working conditions from your amplifiers. So not only does it not have bumps and humps in the impedance curve, but it has also less phase shift, so the amplifier has a much easier job working with it. So you have something very high speed, very fast drive. It's like a car. I mean, it's nice to have a car, but it has 50 horsepower. It doesn't get you anywhere. You need a lot. Yeah, you need a lot to have that acceleration, to have that push. Membrane here is special too. Membranes are made from 2 layers of spread toe carbon around a Nomex honeycomb. And the top layer here is a 4/100th millimeter thick titanium that is then subjected to a particle accelerator and put in and have ions bombarding it for almost 3 days.
So that must mean it's a ridiculously expensive loudspeaker.
The basket, the basket is special too. So a half a kilo silver and a basket made from zirconium. And the net cost price for us for a basket like this is 3,000 euros. So you can start counting.
That's a lot.
So 1, 2, 3 kilos of silver in a speaker and 6 drivers.
Okay.
So of course we come out with sort of like a product that ends up being very expensive because the technologies and the know-how we put in is expensive. But if you want to make a flagship and a state-of-the-art, it is for the selected few anyway.
Then that's fine. But is this going into other loudspeakers like a...
Of course, all the knowledge we have goes into that. And fragments of this membrane, the spread toe carbon and the honeycomb and the spread toe carbon is already present in the Access speakers or the X series of speakers, which are a much lower price point, because we do away with all the expensive stuff and retain some of the qualities there.
Just a brief interruption, esteemed viewers. As you may know, I'm Tom Martin, Chief Content Officer of The Absolute Sound. We have a new product. It's on the Substack platform, and we're going to do some interesting things with Substack. First of which is reader questions and answers. Each Monday, readers will submit questions. We'll pick the most interesting ones and we'll answer the questions on Friday. We'll also have early access to articles and special blogs that don't appear anywhere else. We hope you'll join us. It's only a cost of a cup of coffee per month. Just check on the screen or in the show notes below. Thanks, and now back to the show.
Now we're also here, you're showing, you're announcing a new combined streamer and amplifier. Would you like to put down the silver and talk about that?
Yeah, we have actually a world premiere or European premiere on the Access next door, which is an all-in-one box where we have a streamer and a DAC and an amplifier in one box.
Okay.
Starting at 5,000 euros.
Wow. Okay.
So that is very affordable, very good. We also have the top of the line streamer DAC in here, and that has quite a different DAC process, because a DAC process normally, yes, på ryggen her. A DAC process is normally a discrete process.
Yep.
You get a digital number, you get a package of 16 bits, and that represents a value. That is the height of the signal, and you step that 44,000 times a second for a Redbook CD.
Yep.
And that means that this process this is a discrete process. So you have switching going on, and in every switching there's a ripple. There's a ripple up, there's a ripple down. So you have this rippling effect, and I think that's why digital has not really gotten to the point where it can sound really analog, because it's sort of like a top-down process. The highest level has the lowest distortion, the lowest level have the highest distortion, and it's a pointy process because you have a switch. You switch, you switch, you switch, you switch, and everybody knows in audio that if you have two frequencies very near each other, there will be interference patterns of those way further down, and all of a sudden they bleed down to the audio band. And I think that's why digital has that tendency to be pointy in the treble. This one, we take the same 16-bit, but we keep on upsampling that to get to 22 megahertz. So this rippling effect we push way outside of the audio band. And because it's so far away and the digital signal contains all the audio information from 0 hertz basically until 20 kilohertz or wherever there is music, and that we can filter away in an analog domain instead. So we have a DAC without a DAC, so we take the DAC process from being a pointy switch process into an analog domain, so we have a continuum. And that change, I think, is profound. And all of a sudden we get a DAC that has that ability to play music from below. It has this transient starts from below and not by pointing at you. I think that's really a revelation.
Okay, thank you. I'll leave you to my cough. Thank you very much.